Hi, so we want to finish up Chapter 2 of Brown, Burston, LeMay, and Murphy, Chemistry, the Central Science. Chapter 2 ends with just a little taste of the naming of organic compounds. Of course, this is a big subject, and this is just the tip of the iceberg, but a little less detailed than what they give in this chapter on naming inorganic compounds. So let's dive in. So organic chemistry is not, you might think of it as the study of life because life is based upon carbon, right? Or carbon-based units, as that old first Star Trek movie in the 1980s said. I think it was 80s, might have been 70s even. That's not important right now. But anyway, we now refer to organic chemistry basically as the chemistry of carbon compounds. And carbon compounds, especially bond with hydrogens and oxygens and nitrogens and sulfurs. Oh my. We call compounds that are made of carbon and hydrogen, we call them hydrocarbons. And of course, this is an environmental topic of great interest. Hydrocarbons that come from into the air from fossil fuels and things like this, and how it might damage the ozone layer and all these sorts of things. But hydrocarbons are compounds primarily based of carbon and hydrogen. We basically call a carbon that has four other atoms. So carbon is in the fourth group, and it has four electrons in its neutral state. And so these four neutrons are ready and willing to bond with four electrons from four other atoms. So a carbon with four other atoms connected at each portal. You know, it's like we have four ports on this carbon. And so a carbon with all four ports taken is called an alkane. Anes. So here are the anes. So CH4 is methane. It's a gas. It has one carbon with a hydrogen, 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 hydrogen. So it's like a cross with a carbon in the center and a hydrogen on each port. You know, it's like a space station, and it has four little hydrogen spaceships that have been perpendicular to each other attached. So that's methane. Now, if we have two carbons, but with hydrogens on all the available ports, so for the two carbons to be bound to each other, you have one bond between the two carbons, and that leaves two up, two down, and two side ports, as it were, bonds ready to bond with hydrogens. So that's a total of six, right? Three on each carbon, three hydrogens on each carbon, and then the two carbons connected to each other. This is called ethane. And we can keep going. So three carbons, carbon, 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 with one bond between them. You know, two hydrogens on the middle one, three hydrogens on the outer part of the outer carbons. So that makes eight hydrogens. Propane. I got propane the other day so I could grill out. So these are all gases. And of course, we can keep going. Four carbons, carbon, 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 with one bond between them, three on the outside, two on the two inside ones, making a total of 10 hydrogens around the outside, is butane, which is, again, I believe, well, that's interesting. Propane, that was a liquid, wasn't it? Or is it a gas? I think these are all gases. Please forgive me if I'm wrong, but I believe these are all gases. Octane is not a gas. Octane is, of course, has to do with fuel, high octane fuel we talk about. Octane is liquid. So the longer the carbon chain goes, the more likely it's going to be a liquid rather than a gas. But methane is a gas. Ethane's a gas. Octane has 8 carbons, carbon, 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 with, two hydrogens on each of the inner carbons and 3 hydrogens on the outer carbons. Okay, octane. So these are anes. Anes are hydrocarbons with basically these are binary compounds because they involve 2 atoms. Okay, now what organic chemistry does is organic chemistry, as we go on with other kinds of carbon-based compounds, what we do is we replace you can think of it as replacing one of the hydrogens with some other, what we call functional group. And the textbook I'm following doesn't go into a lot of the other functional groups in this chapter. It just gives you a little taste of what that looks like. We all have heard of alcohol. Some people drink alcohol. Of course, you have rubbing alcohol if you have a boo-boo. The rubbing alcohol is isopropyl alcohol that I mentioned here, that they mention. But basically, the way you form an alcohol is you unscrew one of the hydrogens, and I'm, of course, joking, and you put on a hydroxide, OH minus, onto it instead. Although this is not so much ionic, this is more of a covalent kind of thing. So if you have, instead of CH4, methane, if you unscrew, one of the hydrogens and screw on, a hydroxide, you have, what is it? It's 1C, but instead of 4 hydrogens, you have 3 hydrogens, at least directly, and then you have an OH. So you actually do have CH4O. Oxygen's always come last, I think. No, we call it OH. We call it OH. The OH indicates that it's an alcohol. And so we now call it, instead of methane, we call it methanol. Or if we do this with ethane, we end up with ethanol. If you take propane and you put the OH on the end, then it's propanol. We call it 1-propanol because it's on the end. You can also put the OH in the middle, and then it's 2-propanol. And that's what isopropyl alcohol is. Well, I hope I've not mucked this up too much. So hydrocarbon is a combination of carbons and hydrogen. And they're called an ane if it's just the string of carbons with the hydrogens. But if you take one of the hydrogens off and replace it with an oxygen hydrogen, it becomes an alcohol. So methanol, ethanol, once you get to 3, you have a choice whether to put the hydrogen at the end, which is 1-propanol, or to put it in the middle, which would be 2-propanol. And there are different properties to these depending on where you screw the hydroxide on. Okay, well, this has been a little taste of organic chemistry.